Hi everyone and welcome to today's video on dot plots and column graphs. Yes, this is a Year 8 video, and if you want to know what a dot plot is, a column graph, and how we apply that to mean, median, mode and range and outliers, then you are in exactly the right video. Thank you very much for stopping by. It is awesome having you here. Hi, I'm Darren, otherwise known as MaffsGuru. Yes, I know, a bit of a bizarre title, but I hopefully am here to get you and maths working together, because maths isn't as hard as you might think. All you need is someone to explain it in the way that you understand, and hopefully that is me. Now, if you are new to my channel and haven't already subscribed, can you do me a favor? And over there is a red arrow pointing to a subscribe button. Greatly appreciated if you do. And if you're liking the videos, comment below. Like, do all that stuff that Facebook asked. Now, in our previous videos, if you have been watching along, we've looked at the wonderful world of data representation. We've discovered that there's this stuff called data, and it can be presented as numerical data, and it can be, it's all so exciting. And we did calculations. And the last video looked at mean, median, mode, and range. And we decided that sort of three of those were another way or different ways of finding what we call the average. Now, the range tells us how spread out the data is. It's not a great center thing. It's not a great average. But the median, the middle, is about average. The mode could be average if you look at the idea of the most people. And then there is, of course, the mean, which is the actual average. Now, if you haven't watched the video, please do so. It is awesome, and it will help us sort of scaffold the work that we're going to do. But having lots of raw data isn't necessarily important to us. Our brains like color, they like pictures. And so, ladies and gentlemen, this video is going to be doing exactly that. It's going to look at how we can put data, all of those numbers and those categories and all those type of things, into nice, easy to understand pickies called graphs. Now, the first one I'm going to deal with is what we have shown here. Yes, the dot plot. Now, why is it called a dot plot? Because it is plot what is made up of dots. I know they say maths is hard. Well, it is not. So if we look here, we've got our graph that shows favorite color. Now, I know with color it is not numerical data because color is categorical. It's made up of words, and on the whole, words are categories or categorical data. What do we look at? So up the side of my graph, we have here something called the number of students, otherwise known as my frequency. We can call it the frequency. And along the bottom of my graph, we have the different colors. Now, again, what you'll notice is each of those dots have different colors. There's red and there's green and there's yellow, there's blue, and there is pink. So when you drew yours, if you can use color, thumbs up. I mean, obviously don't spend too long doing color. This is not art. It is not, you're not trying to create an impressionist piece of art. It's not fabulous. It's not the Mona Lisa. It is just something our brain can go, okay, I can see. Now, before I even go any further, what do you notice is the most popular color? Well, because it's the highest, it's got to be yellow. What's the least popular color? Well, of course it's pink. I mean, who likes pink as a color? So automatically I can see that data is sorted for me in a really nice way to see. So each dot stands for an individual person. So each one of those dots stands for a person's choice, and basically they've probably been asked for their favorite color. So how do we know, as I say here, that 10 students have their favorite color? Well, we just count. And in this situation, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, there are in fact 10 people who had red as their favorite color. If we count, we had 5 who were green. I believe there is 15 here. There was 1, 2, 3, 4, 5, 6, 7 people who had blue, and 3 people. Now, do you need to write the numbers on the graph? Sometimes yes. Sometimes it's going to make it easier for you to answer the questions that were coming. And there are always questions that come. So that is a dot plot. And we've got to remember that maths is linked. So mean, median, mode, and range. So let's have a look at our graph again. And let's try and work out what is possible to calculate. And we'll start with the mean. Now, hopefully you're going, but that doesn't make any sense. You can't have an average color. Well, of course we can't. I can't add together red, green, yellow, blue, and pink and divide it by 5 and get an average color, turquoise. Now, you're going to try and say, no, but hold on a minute, MaffsGuru. Each of my columns has numbers. Don't I add those numbers together? And the answer is no, not in this situation. We're looking at the average color, and that doesn't make any sense. So actually, for categorical data, we can't work out the mean. the mean can only be worked out with numerical data, numbers, because we can add numbers together, we can divide numbers, we can't add together words. What about the median? What is the middle color? Now again, you might turn around and go, oh, hold on a moment, MaffsGuru, show me the graph. It's that one, it's green, I'm sure it's green. Well, actually, no, you got the question wrong because it's yellow. But again, to have a middle number, then we have to be able to put the sort of colors in order. Well, which is more important? Is red more important than green? Is yellow more important than red? Now, there will always be a comedian out there going, well, yeah, I like red. Red's more important. Unfortunately, maths and comedy, other than with me, don't really go together. And so median, again, it's a trick. For categorical data, you cannot have a median. Mode, what does mode mean? Well, this one you can have because the mode means the most common. And if we remember from that previous graph, I'll actually just show it, what was the most common color? 'Twas yellow. So in that situation, I can, for categorical data, say that my mode is yellow. And what about my range? Have you already beaten me to this one? For the range, if you remember, what do we have to have? The biggest number, take away the smallest number. We're dealing with colors. We can't have a biggest color, take away a smallest color. And so again, range doesn't happen. So that's awesome. If in an exam you were ever asked to try and work out the mean, the median, the mode, and the range for categorical data, you know it's a trick. You know that you can only work out the most common color. The rest of them, nah, can't be done. Big thumbs down. All right, so what else? Can we place gender? No. Here's an example now with numerical data. So we've already said we can have numerical data and we can put numbers in order. Now, what we've got here is a Pets at Home survey. This question is taken from Cambridge Essentials. Thank you, Cambridge, for letting me use these questions. Here up the side is my number of students, and here along the bottom are my number of pets. And what do you notice about the number of pets? 0, 1, 2, 3, 4, 5, 6, 7, and 8. And so the great thing is we now have the numerical data, which means I can work out my mean, my median, my mode, and my range. But a lot of people get very confused with these graphs. They go, well, I don't know what's going on. Each dot stands for the number of pets at home. So if we look at this column here, we have 5 people were asked with no pets. So I have 1, 2, 3, 4, 5 zeros. That's all that chart shows us. 5 people had no pets. How many had 1 pet? Well, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 people had 1 pet. How many people had 2 pets? There were 4 people who had 2 pets. Now, obviously, I'd normally try and write this in a long line, but I can't do that because I'm going to run out of space. 2 people had 3 pets, and 1 person had 8 pets. And do you notice that that 8 seems to be separated away from everyone? Do you remember what that was called from my last video? Well, hopefully you do, but there's a question on this coming up. So this data here, listed as numbers, is exactly what that graph there is showing me. So now we can actually zoom in, and let's see if we can answer some of those questions. Question A, use the graph to state how many children have 2 pets. Well, that's awesome. I can literally read off my graph how many dots, or how many people had 2 pets. 1, 2, 3, 4. There were 4 people. How many children participated in the survey? So that just means how many people were asked. Well, I'm just going to add all the dots together. So 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, and 22. There were 22 dots there. What is the range of values? Okay, so in that sense, what was the biggest number of pets and what was the smallest number of pets? Well, if we look, the biggest number of pets was 8. Our smallest number of pets was 0, and that's why writing them in a line actually really, really helps, because I've got my biggest number, I've got my smallest number, and so my range in that situation would 8 take away 0, which is 8. Now, the number of people who will write their answer as 8-0. Sadly, that's incorrect. It's not the right answer. You have to do 8 minus 0. What is the median number of pets? Well, having written them out in a long line, I can now cross numbers off the start, cross numbers off the end. So 1, 2 off the start, 2 off the end, 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 1 off the start, 1 off the end, 1 off the start, 1 off the end. And lo and behold, I've got 2 numbers in the middle. Now they're both 1s. And what's halfway between 1 and 1? It is 1. So there you go. So I now know that my median number of pets is 1. If you don't understand why I'm crossing off from either end, go back to my previous video. Have a look. It explains the process through which we do this. What is the outlier? Now, do you remember? I sort of talked about this a moment ago. The outlier is the one that just sort of sits out there on its own. And in this situation, the outlier is 8. And what is the mode? Which is the most common number of pets? Well, reading from this graph here, it is 1. That graph is freaking awesome because it gives us all of that information that I can then do my mean, median, mode, and range. Right, that was, what was that? That was a dot plot. Now, again, here is some more data just to show again that sometimes our data is just drawn in loads and loads of numbers. Can you spot the outlier? Can you spot a number that seems out of place? I'll give you 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. Awesome. Did you find it? It's like one of those random things you find on Facebook. There you go. -3. That would be considered an outlier because it doesn't fit the rest of the data. All the rest of that data is positive numbers. -3 is the one that seems out of place. That's the one to remember for outliers. Now we're going to move on to the excitement that is column graphs. Column graphs are the one that probably you are the most familiar with. Why? Because they show information in columns. But the interesting thing is column graphs are no real difference than dot plots. You know, a dot plot was just dots that were basically put in a column. A column graph actually is more colouring in to do, if I think about it. It's a bit weird. But once again, here is my information that I had the previous time. We've got my favourite colour, we've got my number of students, and once again, across the bottom, what do I have? I have my categories, I have my colours. And all I've done is they've drawn a graph, or they've drawn a bar that goes as high as each of the favourite colour, each of the numbers of people that were asked, numbers of students. So this first column was 10 high, then 15 high. This one here was 7 if I remember, and then 3. So the same difference, this one here was 5. So it's just the same information but with a column. The important thing to know with column graphs is there are gaps between each of the columns. Do you notice? There are gaps here, there's a gap here, there's a gap here, and there's a gap here. Sadly, if you don't draw those gaps, you actually get the graph wrong. And there's lots of marks that are actually given for column graphs, believe it or not, and dot graphs. So how can we give lots of marks? I'm just deleting this stuff here so that I can show you why. Firstly, you have to label your axes. So that one on the top there, on the side, the number of students, that will actually get you 1 mark. This one here, collar, will give you 1 mark. A title will give you 1 mark. A good scale, making sure that the numbers go up evenly, will give you a mark. The bars drawn correctly gives you a mark. I think we're on 5 marks already. And if you have the gaps in between, you'll get a mark. That could be 6 marks for drawing an awesome graph. Now, generally speaking, we ask people to colour these in. Sadly, there are no colours. There's no marks generally for colouring them in. So I suppose the next question is, well, what's the difference between the graph on the left of your screen and the graph on the right? Absolutely nothing, except they've taken the column graph and turned it into a column graph this way. So we can have vertical column graphs, we can have horizontal column graphs. Column graphs. Exactly the same information has been shown, exactly the same height. So the red, once again, is still 10. How do I know this? Draw a dotted line, and what does it notice? It's got 10. We've got colour, we've got a title, we've got axes labelled, we've got a beautiful scale. It doesn't actually matter whether we draw a column graph vertically or horizontally. The point of it is, most of the time we draw it vertically. Now, what type of data is being shown? Once again, it was categorical data, and so we cannot find the mean, the median, or the range, but we can find the mode. For those of you who want to, you can actually download these notes from MaffsGuru.com when I upload the video. It normally takes a day or two to upload the video. It gets onto YouTube first, and then I add them onto my website. And so you might want to cut bits of these notes out and put them in your summary books. Well, that's awesome. That's great learning. But you have to read the notes. You have to try and understand it. There's no point just cutting stuff out, sticking it in a book and say, I is learning, because you is not. I promise you. And I is not a good English teacher. So the hard part about drawing column graphs is making sure that you use a good scale and know how to read a table. And it just so happens I have a fabulous table here representing people's heights. Now what do you notice? We've got Tim and Phil and Jess and Don and Nairi. And below each of those names is a height. So we've got to now try and draw that in terms of a column graph. How am I going to do that? Well, the first thing I'm going to do is I'm going to draw some axes. Now you're going to be able to draw these much more accurately than I am. What goes on the bottom, do you think? Well, if you remember back to our colours, the colours went on the bottom, and so our categorical data will go on the bottom. So I'm going to write, there we go, Tim. I'm probably going to run out of room. Phil. Who's next? Jess. I'm going to do Dom. And then I'm going to do Nairi. Okay, so not bad, I got that in there. So now what goes up the side? Well, the only thing that's left is the height. So I'm going to write height here. And I need to come up with a really good scale. Now, sadly, there will be people out there who will go, okay, so I'll have 150 here, and I'll have 120 there, and I'll put 140 there, and I'll put 100 there, and I'll put 130 there. Now, if you are one of those people, I'm so sorry, but that's wrong. Yeah, remember, scales always start from 0, and they go up with an even distribution. So I've got to get up. My highest number is 150. So actually what it's going to do is I'm going to make sense to go up in 20s, because 10s would be too small, 50s won't work because of the distances, and I'll show you why. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So 20, 40 and 60 and 80 and 100, 120, 100, nearly 140 and 160. So actually as it stands there, I do not need the rest of that, and I can rub it out and make my scale fit beautifully. So what do I do now? Well, now I draw the columns. So Tim, reading off, was 150. So what I'm going to do is I'm going to go a column up to 150, across and down. Colour it in. There we go. Timmy boy, that's you. What about Phil? Phil's 120. Now remember, we've got to make sure that we keep those gaps. So there we go, drawing it, doing a bit of shading. I'm doing a boy shade, those little chevrons, the little marks, that's a boy shade. Then we go, Jess is 140. God, sorry, Jess, you is old. Hold on a moment, we're dealing with age. MaffsGuru, we're dealing with heights. So there's 140. Don is going to be 100. Don is good, yes. Don is good, yes. Now, if you're out there in the United Kingdom or America or India, you'll have no idea what I'm talking about. But over here in Australia, we have a slogan. Don is good, yes. I have no idea what it means. Nairi is 130, so let's find you Nairi, roughly speaking 130. Now obviously I'm drawing my graphs with electricity, I can't make them accurate, but your books will have squares in them so you can draw this accurately. Now my columns aren't the same width, they wobble going up, but I'm just giving you an idea of how to draw it, okay? So what am I missing? People's heights, I need a title, and lo and behold, what do I have to put along here? The name, and there we go. I get a pretty awesome score for that particular graph. Now maths is a big fat trick. Thank you, Barry. We obviously realize that you are not a very nice person, and they can show you all sorts of column graphs in all sorts of different ways. So if we look at this one here, again extracted from the Cambridge Essentials textbook, what are they showing us? Well, along the bottom I have years, 1990, 1995, 2000, 2005. Now in this situation you might think that that's actually numerical data because it's got numbers in it, but actually it's not. We're actually using that as categorical data, and it's sometimes not easy to tell the difference. You just need to practice. But if we look at 1990, I've got 3 columns for 1990. One's a blue column, one's a red column, and one's a green column. And that's where the key here comes in really handy, because the blue stands for the number of employees who take public transport. The red, number of people who take car, and the green who take bicycle. Now, why on earth would we want all of these years on there? Well, the great thing about statistics is we want to compare stuff. We want to be able to look at things and say, well, okay, which year did the most people take the car? Well, car is red. Here is what seems to be the mode for red, and so I'd write down my answer as 1995, which was the least year who walked or bicycled. Well, there we go. This seems to be the lowest one. 1990. So being able to read these graphs is really, really important. Over here we have another example of a column graph. Now if I zoom in, what we notice is it's very, very similar to what we had before. Here are my years, 2010, 11, 12, 13, 14 and 15. But what do you notice about my actual columns? Well, rather than being side by side, what we've actually done is stack them on top of each other. So this column here may have started side by side as there's my blue, there's my red, and there's my green. And all we've done is we've taken each of those little sections and stacked them on top of each other to make one bar. So there we go. Green stands for interstate. If I could read this scale, then I would know how many people went from interstate, because I would just read off that little slice. And another one that you're going to get to next lesson is something like this. This is just awesome. Next lesson we're going to deal with stem and leaf diagrams. And they are amazing, they're fabulous. But this one here is a dot plot. But what we notice is we've got dots above a line and dots below. Why? Well, because we can actually compare two classes. All the dots above belong to class 3M and all the dots below belong to class 3S. So the interesting question is, what's the mode for 3M? If we look at 3M, we're looking for mode, which is the most common. That seems to have the highest, and so it is 8. But what's the mode for 3S? Well, if we look at 3S, we're looking for the highest column. Now, obviously it goes down, but you can turn your book around if you need to. And what do we notice? This is my highest column here, which is 7, and so we can start to compare. These particular graphs are just awesome, and they come through in maths all the time, but you don't have to worry about it. You just need to learn at this moment in time about dot and column graphs. Well, I don't know about you, but I think I've learned a lot. Have you learned a lot? Well, hopefully you have. I should be growing bigger because we're getting to the end of this lesson. Thank you so much for watching. If you haven't already done so, can you do me the favor of subscribing? Awesome, if you can. Now, I only need another 7 subscribers and I'm up to 700. I am so proud of how this is going. There is a circly thing over there for you to click if you haven't subscribed, and there's a video appearing below it for you to watch as well. Otherwise, I'm done. Good to see you. This is MaffsGuru signing off. Bye-bye.